Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is from Mellanox. We have Gilad Shainer. He's the VP of Marketing at the company. Gilad, welcome back to the show.
Thank you very much, Rich.
Hey, it's great to have you back, Gilad. I kind of lost track of all the things going on with InfiniBand and Mellanox these days, so I'm glad we have a chance to get together here right before SC18. And I understand you've got some really good big plans coming up at Mellanox for the show.
Yeah, that's true. And yes, it's part of driving leading edge technologies for high performance or AI. It's never adding excitement from that perspective, right? You
Yeah,
always create new things, bring more technology or new technology,
yeah,
drive new performance levels, being part of building the fastest supercomputers in the world. So
yep,
it's always there are new things that are happening.
yeah, yeah.
Um, so definitely, we were very proud and today very proud to be the interconnect solution for the top three supercomputers in the world.
Hmm.
I think that's the first time actually for InfiniBand to connect all of the top three.
Yeah, I would think so because typically that's been the space where the proprietary, expensive things have happened, right? Those kinds of interconnects. But to have a standard up there at the very top, that's just outstanding.
Yeah, InfiniBand did connect some of the top systems.
Yeah.
InfiniBand connect the first petaflop system in the world, the
Hmm.
Roadrunner.
Yep. Yep.
And was on the top of for several years. We always had several systems in the top 10 or the top 20,
Right.
but now we have the all of the top three,
Yeah.
which is definitely amazing. And if you go to the next slide, so it's not just the top three, which is the fastest supercomputer in Oak Ridge, and then the second one in China, and the third one, which is another Coral system in Lawrence Livermore.
Yeah.
But we're also connecting the four of the top five. So
Mm.
system ranked number five today. That's the fastest HPC and AI system in Japan.
Yes.
So it's definitely we're seeing a very good usage of the in-networking acceleration engines in InfiniBand to drive faster speeds and better performance.
Hmm.
Um, we're also connecting the fastest industry supercomputer, kind of the commercial supercomputer, which actually deployed in Europe for oil and gas explorations.
Yeah.
And we were also proud to be the network for the first large-scale ARM-based supercomputer that is being built. It's on the National Lab, and we probably expect to see that in the coming top 500 list. And
Yeah.
it's showing that InfiniBand deliver high performance, and you can actually use it for any compute platform out there.
Hmm.
If it's an x86 or Power or ARM or GPUs and so forth.
Yeah. Yeah. Is that machine from HPE, that Astra system?
Yeah,
Yeah,
that's
that's what
that
I thought.
machine. Yes,
Okay. Yeah.
yes.
Okay, cool, cool. All right. Well, great.
Yeah, if you go to the next slide, I think the couple of few slides from I'm going to go through some of the major technology advantages that we bring. Slide number four, we talked about the transition of the data center architecture, actually moving from a CPU-centric architecture that requires to move data all the way to the CPU before you can analyze the data to a data-centric architecture, which actually drives the different approach. So instead of driving data to the compute side, you want actually to bring compute to the data. Right? If you have exponential growth of data, you want to analyze things faster, you want to run more complex simulations. Moving or the need to drive data to the compute actually is not something that can scale. And moving to the data-centric approach where you bring compute to the data actually enables you to overcome performance bottlenecks. For our side, what that means is actually bringing the in-network computing acceleration engines, which those are engines that enables to run data algorithms on the data itself as it being transferred within the data center, and with that actually ability to overcome performance bottlenecks, to run applications in a better scalability and higher performance. Um, if you go to the next slide, here list of some of those elements. I think that one of the the major elements is the Mellanox Sharp, which stands for Scalable Hierarchical Aggregation and Reduction Protocol. That engine enables to run data aggregation, data reduction protocols on the network, which means we can move NPI collector operations to the network. We can offload part of the AI frameworks or the deep learning frameworks and so forth, and actually reduce latencies by 10x, more or less, from the performance people see running the same operations on the CPU versus running that on the in-network computing elements. So Sharp is one example. We also have engines to run NPI tag matching and rendezvous protocols on the network, ability to accelerate NVMe over fabrics. We also start supporting now security accelerations, be able to do encryption, decryption on the network, for example. And there is multiple other examples. And if you go to slide number 6, I think this is kind of the summary of the performance benefits that people can see. So Sharp, it's definitely one of the most important in-network computing element. It was developed together with some of the government labs out there, and actually enables very high performance and overcome performance bottlenecks that people see for AllReduce operations, barrier, broadcast, and so forth. We see very nice performance improvements on tag matching and rendezvous offloads, also driving elements around self-healing technologies for making the network much more resilient, and other elements such as GPU-directed RDMA and so forth, which enables to one side offload the CPU so the CPU can actually be focused on data analysis, but moving some of the data analysis also to the network to be able to actually move compute to the data. On the next slide, I did wanted to put a couple of graphs here on performance level. Those are data that were tested, data points that were tested on SciNet, which is the largest supercomputer in Canada, deployed at the University of Toronto, 1,500 nodes, and it's actually the first large-scale InfiniBand Dragonfly based topology that was built. I think it's running for a year now and showing very nice performance. Now, that system utilizes Sharp, and with Sharp running the aggregation protocol on the network, you can see the dramatic performance improvement. So the graph on the left is looking on NPI AllReduce latency, or NPI AllReduce performance, in running one process per node. So you actually have 1,500 NPI ranks running. The orange line or the orange bars, that's the latency that you see running that operation on the software side or on the CPU. And then the blue bars, this is the latency running AllReduce operation in a variety of message sizes on the network. And you see the dramatic reduction in latency. On the right side, this is a probably more interesting case because this one is actually running 40 processors per node, or a total of 60,000 NPI ranks on that system. And again, you see the dramatic reduction in latency from running AllReduce operation on the CPU side versus running that on the network side. Now, two things to add here is essentially if you want to reduce the AllReduce latencies, adding more CPUs actually just does the opposite. And the only way it's kind of moving the algorithm to the network. That's one thing. The second thing is that once you run AllReduce in the network, you don't just benefit from major reduction in latency, you also benefit from less amount of data that needs to move because it does reduce the data motion. So there are actually great benefits around that, and that's why Sharp becomes a very critical technology or acceleration engine for a variety of high performance or deep learning applications. So Sharp, delivers a great performance for high performance computing applications, but Sharp will become a very critical also for deep learning. And if you look on parallel deep learning, when you actually need to deal with larger data sets and build more accurate algorithms, the way that it's being done is that you create training agents for the training sequence. You create training agents which runs on CPUs or GPUs, for example. Each training agent get a different data set, but the same weights for the neural network algorithm. And then each training agent will test according to the weights or the set of weights that it got, and then it will report back the delta in weights, meaning what's the difference, what's the error. And all of the training agents will report their information back to an entity that it's called the parameter server. That parameter server will get all of the delta weights from all of the training agents. It will do a reduction operation and actually send back a new set of weights, and so forth and so forth. So actually what the parameter server entity does, which actually today runs on multiple CPUs, it's doing an AllReduce operation. And this is where you can actually take the parameter server entity and instead of run that on multiple servers, actually run that on the network. So you can get much lower latency, things can be run in much higher scalability, and that's the future of deep learning frameworks. So, and we will see Sharp being incorporated in multiple of those. So that's why in my eyes, Sharp is one of the key technology. It's greatly impact the traditional high-performance computing applications, and it will become critical, very critical, to enable faster speeds and more performance for deep learning frameworks. So if you go to the next slide, so actually we are very, very excited as we start. We released the first HDR solutions out there. Just as a reminder here, the new generation of HDR 200 gigabit per second InfiniBand includes ConnectX-6, which is the network adapter that supports PCI Express Gen 3, PCI Express Gen 4, delivering 200 gigabit per second, less than 600 nanosecond latency for an end-to-end connectivity between servers, and drive more than 200 million messages per second. And Quantum, which is the HDR switch with 40 ports of 200 gigabit per second, where each port can be split into 2 ports of HDR 100, 400 gigabit per second, to a full radix of 80 ports of 100 gigabit per second. We of course have the set of cables and transceivers and a full comprehensive software stack for supporting MPI, SHME, PIGAS, and UPC. And again, we're very excited to release HDR and see the first systems coming out. And if you go to the next slide, so recently there were 2 great announcements. One of them was from Tech, which announced the new Frontera supercomputer that will utilize HDR InfiniBand to bring higher performance, better scalability to tech applications and users. That system will be built end of this year and towards the beginning of next year. So we're going to see it next year up and running. If deployed today, by the way, Frontera would be one of the top 5 supercomputers in the world. Definitely the fastest supercomputer in any university in the US. So it was great to see that announcement. And also, University of Michigan has put an announcement out there, which they are building now the first HDR 200 gigabit per second system in their center to enhance the capabilities that they offer to their users. We have many more HDR systems being planned, and we'll see a lot of them coming towards the end of the year and into 2019 and beyond. So if you go to the next slide, so HDR InfiniBand, brings the fastest throughput with 200 gigabit per second, much higher message rate, all the smart acceleration engines or in-network computing such as Sharp and MPI tag matching and Rendezvous and so forth. But also with the increase of the switch radix that supports 40 ports of 200 gigabit per second or up to 80 ports of 100 gigabit per second, you can actually build a more cost-effective and scalable infrastructures. With 2 tiers of switches, you can build 3,200 node system. And if you go to 3 tiers, you can cover 128,000 nodes with the 80 port radix. So it brings much more savings from number of switches, cables, infrastructure, and so forth, and be able to build higher scalable infrastructures, more performance, and definitely in much higher return on investment. And the next slide, and if you take the advantages of InfiniBand, that translate, of course, to benefits or performance benefits on the application side. Multiple examples out there. If you look on weather codes or automotive crash simulations or chemistry or genomics, model dynamics, oil and gas, and so forth, we see in every application the performance advantage the InfiniBand provides versus other offering out there in the market. And if you go to the last slide, so definitely we were very excited before supercomputing. We released HDR, so we start shipping HDR, and we see the first system being built. So it's very always very exciting to see the next generation coming out and the usage of it and the great benefits that it brings for its users, if it's a performance or scalability, efficiency of the system. So we're definitely looking forward for supercomputing, for seeing more announcements around that. And I do want to invite everyone to join our annual event at Supercomputing, which happens on the Wednesday night of the Supercomputing week. The event will take place at the Sheraton Dallas Hotel. And if you go to Mellanox website, www.mellanox.com/SC18, you will see all the information about the event and how to register and so forth. We will be presenting news around the technology and what's coming next. We'll have great guests that's going to talk about their view of the future of HPC and how they work with Mellanox to build it. Very happy to have Dan from Tech to talk about Frontera and the future of HPC. And of course, we'll have a great entertainment, and we have one of the world-leading mentalists that's going to be on stage, and it's just going to do wonders. So want to invite all of you guys. Seats are limited, so please go and register. And looking forward to see everyone and definitely seeing you, Rich, at Supercomputing in Dallas.
For sure, Gilad. Hey, that event sounds terrific, and I'm wondering if this guy's gonna hypnotize people or if he's just gonna read their minds. Do you know what he does?
Yeah, I saw some of his shows. He's
Yeah,
definitely read people's minds and discover your first girlfriend or boyfriend
yeah,
and what's your credit card secret number and so forth. He's doing
really.
amazing things.
Yeah.
It's not to miss show in
Okay.
my eyes.
Yeah, yeah. Well, great. Well, Gilad, I can't let you go without asking about the student cluster competition, which is a big part of SC18 as well. And how's that going from your perspective?
Yeah, so for supercomputing, we do help some of the teams.
Yeah.
And we did sponsor some of the team with InfiniBand network for their systems, and definitely we wish everyone good luck and success there. By the way, we have also the student cluster competition that will come in at ISC, at International Supercomputer in Germany in June, and the call for participation for student teams is open on the HPC Advisory Council website, which will close the week before supercomputing, and we'll
Oh,
be
yeah.
announcing the teams that will participate in Germany next year at the last day of supercomputing on the Thursday.
Yeah.
So I'm
Okay.
also looking forward to see potentially new teams from new countries, as I think it's very important to us to see
Yeah.
more HPC education in more countries and more universities.
Yeah. Yeah. Well, Gilad, sounds like super exciting times for Mellanox with HDR shipping and some big systems relying on that to get that scalable performance. So congratulations on that. And I always ask this, but what comes after HDR? What's the roadmap look like?
Yeah, so HDR is 200 gigabit per second. The speed after it's NDR, which is 400 gigabits per second per port. And believe me that as we start shipping HDR, we have teams that already start to work on the next generation of NDR InfiniBand.
Well, that's really exciting. Well, Gilad, I really want to thank you for coming on the show, and I'm looking forward to seeing you guys at SC18 in Dallas, Texas.
Yeah, thank you very much, Rich, and looking forward to see you as well.
Okay. All right, folks. That's it for the Rich Report. Stay tuned for more news and information on high performance computing.